Okay, so what we have done till now is yesterday we were working with this interactive shell. Let me bring my interactive shell up and running first. After this interactive shell was up and running, we went ahead and told that I will install Kubernetes, sorry, not install Kubernetes, install Helm. So here I will go and say minikube start. So I will start my minikube. Meanwhile, once the minikube is starting, I'll go ahead and say I want to install Helm. And here I will go ahead and say I want to download Helm. For that, I have to run these three commands. So this is installing Helm 3 first, then giving chmod to that guy, and finally running the script. So I'll wait for my server to come up. So this is done. Now I'll install Helm here. Once this thing is done, I will come here and say chmod 700, the script. And finally, I'm going to run the script. Now, once this is done, I will clear all these things and I'll simply come here and say Helm version. So yesterday, this is the first thing what we did. We went ahead and installed Helm on our Kubernetes machine. Once Helm is once Helm is installed, I will go ahead and do my work next. So when I say that I'm going to do my work, I can simply go to Helm Hub or Artifact Hub. And from here, I can pull any image of my choice. So yesterday we started with Nginx, and I told that I'm going to work with this image. Now to work with this image, I told that you don't have to do much. You have to do a repo add and repo install. Once your work is done, you simply go ahead and delete the repo. So let me do it one by one. So this is what I'm going to do first. I'm going to do a repo add. Paste. So this is a repo add. Once repo add is done, you can simply go ahead and install the repo which has been created. So come here and paste this content. And here Helm install, whatever name you want to give. Inside my repo, there is an Nginx image which is running. So yesterday we were able to do all these things. So if I come here and say kubectl get all, I can see that the entire component which consists of pod, service, deployment, replica set, everything has been installed. In case you don't want all these things, you can simply come here and say that I want to delete all these things. And to delete all these things, the simple command is helm delete and the name of the Helm chart which you have created or Helm repository image which you have pulled. So let me come here and paste this guy. Now clear all these things. Now, so one thing which I know is Helm will contain the content which I just readily want to use. Now, what can be a given scenario or what can be a requirement where I have such a scenario? Now, let me give you a very simple example. Let me say I have 3 projects which are running. Project A, B, and C. Project A has implemented something. Let me say they have implemented the monitoring aspect, and I want to replicate that in B and C. Not only inside same organization, probably there are many organizations who will want to monitor the application. And when I say they want to monitor the application, they use the same set of parameters, same set of ways to monitor everything. Okay, so I can go ahead and start my work. Okay, Alternatively, you can create your own Helm repository or Helm chart, okay, and you can share it with your colleagues, your friends, your company people, and all those things. So let's go ahead and create or use an image which is very readily available, and from there I will be going ahead and creating my own stuffs. So let me go ahead and go to my GitHub repo, and from here I will try to install something which is like very easily available. Okay, so I will be trying to monitor my Kubernetes application using these content. Artifact Hub is like Nexus. You have many Artifact Hub, Nexus, JFrog Artifactory, and you can use them as per your requirement. So this is Helm. In this Helm, I told that I will be going ahead and dealing with two more components, Prometheus and Grafana. I told Prometheus is majorly used for collecting the metrics or collecting the data, and Grafana is majorly used for showcasing that in a graphical manner. Okay, both are open source, you can easily use it, and using Helm it becomes very easy for you to work with that. So Prometheus is an open source system for monitoring and alerting the application, originally built on a tool called SoundCloud, but now it is easily integratable with your Kubernetes. Similarly, here I have something called Grafana, which is used for analytics and visualization. Alert Manager is a tool which will help you to send alerts from Prometheus server. So we'll see all these things one by one. Now, if I have to work with this, I can simply come here and download this from my Helm hub. So I can simply come here to this guy, and I can simply say that if I come here and say Helm search repo, so these many things are there, and all these things are inside my repo, right? And in this my repo, I was using Nginx. Okay, so as of now, I don't want this, so you can leave this as it is. I want to add something else. Okay, so when I say I want to add something else, okay, so if I say I want to add something else, let me come here. So I'm saying Helm, there is a repo which is here in this URL, Helm chart basically. Give me 1 second, please. So I'm saying there is a Helm chart with the name as stable, which is there in my Helm hub. And I want to download it to my local machine and give the name as stable. So I'm doing a repo add. If you want to check this stable repo, you can come back to your artifact hub and you can take it from here. So stable. So you can see some stable thing is there. Okay, no, not this guy. Search on 183. So this is what I'm going to work with. Okay, so this is your Helm hub. So it is Banzia Cloud Stable, whatever it is, but I have named it as this thing. So if I come here, this is what I'm trying to access. Okay, so there is a Helm chart with a name as stable, and this is what I'm trying to access. So it says, so there is a documentation which I've already taken here. If you want, you can read through this documentation. It says, first you do a Helm repo add, give a name, and then add this to your local. Once this is done, you go ahead and install this. So how to install? So this is the next set of commands which I'm going to run. So here it says stable you have added, then you add Prometheus community version. Again, it is coming from Prometheus community edition. So add this Prometheus community edition to your local machine. Let's copy this. come here and add this guy also. So why are we doing this? Because we cannot directly run it from our Helm hub or artifact hub. When we were using Docker also, we first do a Docker pull, bring it to our local, and then we do whatever we have to. Similarly, here I have added two repos, one with the name as stable and the other with the name as Prometheus community. Okay, now these two have been added. Now I can go here and search for this repo. So let me come here to this Prometheus community thing, whatever I have added, and give it here like this. Maximize this. Paste. So I'm saying you have added a repo called Prometheus community. Inside that Prometheus community, what all are there? So here you can see there is alert manager, Kube Prometheus stack. Now what they will do, the description is there. So it gives alert man, this guy gives alert manager. This collects your metrics from a Kubernetes cluster. Okay. Suppose you are using a Kafka application, you can use this. You can using a MySQL application or a MongoDB application, or you are using any other application. So depending what kind of application you are using, there is a ready-made solution available. So my motto is this guy. I want to integrate it with Kubernetes. Yes. Okay. So this is what I want to work with, because I want to collect all the data from Kubernetes or Kubernetes cluster which is running. Here it's a mini cube, but still I want to collect all the data, like what pod is running, what API server is running, how many containers are running. So all those details I want to collect. So this is what I want to work with. So to work with this guy, I will have to do something like this. I have to simply come and say Helm, install this particular component. So what is that particular component? Prometheus community. Inside that there is Prometheus stack. So this is what I want to work with, or I want to install in my local. As of now, I don't have anything. Whatever I had, I have already deleted it. So let me come here and say clear and paste this guy. So I'm in the stable. There is something called Prometheus community, and inside that there is something called Kube Prometheus stack. So that is what I'm trying to install. So basically when I run this command, there are like some 10 to 15 components which will be created. So just give me 2 minutes, it will get installed, and then I will go back and show you that there are 10 to 15 elements which just got created. With a simple command, Helm repo add and Helm install, you will be able to get all those things. If you don't do it via Helm, then you have to sit and write all these things from scratch. So if you see here, it is saying it has been deployed and the first version is deployed. Now, if I come here and say kubectl get all, I can see these many pods are running, these many services are running, these many deployments are there, and these many replica sets are there, and there is something called stateful set, which we did not cover yet, but we will be covering. So there is a stateful set, there is a replica set, there is a deployment, service, pod, and many things like that is running. If I had to do everything from scratch, I had to sit and write the manifest file. But think like there is a senior developer in my team who has written all these things, and he has made a Helm chart out of that, or he will say he has made a Helm chart out of that and he has pushed it to Artifact Hub. So what I have to do is I have to simply take that image and use it in my machine. So let me just come here and clear all these things and run this command again. I want all the containers, everything to be up and running. So now if you see here, there is Alert Manager, which is up and running. There is Prometheus. There is some PT Spark, Grafana is there. Then you have Kube Prometheus operator, Kube metrics operator, and Kube Prometheus node exporter. So basically these are internal components of Prometheus, which will help me to scrape the data or collect the data. Whatever application you want to monitor or hardware you want to monitor, that data it will scrape or it will collect. Okay. Once it has collected it, it will go ahead and give it to my my Grafana to monitor it. Okay. So why am I using Helm? If I don't use Helm, all these manifest files, deployment, surveys, stateful set, I have to sit and write. Okay. But now I'm saying I know I don't have to write it. I will simply run repo add, Helm repo add, and Helm install, and my work will be done. If the today's class permit, I will also show you how can I create my own Helm repository. Okay, so I'm right now using a Helm repository which has been created by Prometheus Community Edition stable, and inside that I have my content. Okay, so this is what is running for me. Now, if you see carefully, all these services are cluster IP. So cluster IP, I told you, is majorly used for internal communication. If I have to go for external communication, I will have to change them to load balancer or node port. So let me say this is the guy which I want to change because it is Prometheus STA. Prometheus, I think STA operator I have to change. Let me just check from here. So it says that once this is done, you can go and edit your Prometheus STA Prometheus. This is what you have to edit. So let me take this command. So I'm going to edit that so that it becomes load balancer and I can work with that. So let me clear it first. And if you come here and say kubectl get SVC or service, you will be able to see your service. Now I will run this command, which says kubectl edit SVC, which is service, and this is what I'm trying to edit. Stable Prometheus STA Prometheus. This is the guy which I'm trying to edit. What am I trying to edit? So it is cluster IP. I want to make it load balancer. So I'm using command kubectl edit. Enter. So this kind of screen will open. You have to change this. So the moment you do escape key, it will become small. Again, use escape key, means escape 2 times. Then I. So when you say I, it will come in insert mode. Now you can maximize it. You can see it is in insert mode. So all the way you have to come down. Here you can see the type is cluster IP. So you have to make this cluster IP as load balancer so that I'm able to expose it to outside world. Load balancer, BALANCER. Make sure that the spelling is correct. Okay. Once this is done, come here, escape colon WQ exclamation mark, means write, quit, and exit. I can show you that. See, in the down I have written colon WQ exclamation mark, means write, quit, exit, and this is the piece of code which I have changed. Enter. So now what you will see is that it will get changed. So if I come back here and again run this command, it says that this Prometheus thing is a load balancer, and the important thing is that it is running at 31288. So let me see whether it is running or not. So let me come here and say 31288. So if you can see in the top, you can see Prometheus time series is starting. At least it has started. So it says starting up. Now here there are many things which are getting scraped or the data is getting collected, but there is a small problem with Prometheus. Now Prometheus is open source, free of cost, everything is okay. But Prometheus, or to work with Prometheus, you need to learn this language, PromQL or Prometheus query language. Okay. Now this Prometheus query language is not that simple and straightforward to learn. Why? Because it is not a simple database, or it is not a simple type of work. It has time series database. Okay. So time series database is something very much new to everyone. So they don't want to get into the complexities. If you just want to see how it looks like, you can simply come here and try to see how to write all these things. But in short, it is complex. So none of the companies also want to invest time and money here, like what is range vector, instead vector, literals. So this is very difficult. Okay. So they don't want to invest time here. I'll show you why they don't want to invest time and money here. So nobody will ask you whether you know PromQL or not. So the data has to be retrieved in this fashion. So it is basically a bit complex thing. So if you see here, you can come to status. Here you can go to targets. And if you see here, these are the unhealthy targets. Now, if you want to go inside and see what is that, click on this guy, get error. Let me come here. click on this guy, endpoint. So it will take you to see that the data is put in a time series format. The connection got interrupted. Why? See here, I got disconnected. I don't know what happened to the internet, but I got disconnected. So what I have to do is I have to close this guy. Now, this is a problem with this interactive shell which you work with. The data does not get stored. So in case your machine stops or internet is gone, then you have to restart everything. So let me just quickly go ahead and start all these things, whichever I have done. This is the command to install Helm. So I will take this command and keep it ready with me. Come here. So the first command which I generally run is minikube start. So let minikube start, or let Kubernetes start here. After that, I will go ahead and run Helm on top of that. And then again, I'll start my work, because whatever I was doing, it got interrupted in between. Basically, I was installing a Helm, and I first installed Kubernetes. Then on top of that, I installed Helm. And then on top of that, I added a repo and then installed the component which is there in that repo. And then I was able to see everything, but the content which I had was more of a cluster IP. So I would like to go ahead and put it as load balancer. So this is my Helm getting installed. Helm is done. Let me clear all these things and let me come back to this thing. So I will simply run these three commands here. So the first command is helm repo add. Then you are searching the repo, and after the search is done, you are installing the repo. So Helm install is running here. Let it run. The Helm install stable Prometheus is going to take some time. That's the step which takes time.
Don't you have it?
Okay, so this is going to take some time. Okay, so it says it is done. Let me clear all these things. Come here and say kubectl get all. So you can see all your components. Just give it some time. Okay, so you can see your containers getting created, your pod getting initialized, but still I can see these guys. These are cluster IP. So I told that I'm going to edit this guy. So I will copy this guy and say kubectl edit, or I can take the command directly from here. That is also going to help. paste this guy. So this will open like this. So you have to say escape 2 times. So if you give 2 times escape, it will come here and then say I. So it comes in insert mode. Once it is in insert mode, go all the way down here and this type whatever you see as cluster IP, make it load balancer. So this is what we are doing. We have changed it to load balancer. Again, escape colon WQ exclamation mark. So this component will be changed. So I can see here that this component has been edited. So if I clear all these things and come here and say kubectl get SVC, I just want to see the service. So I can see one of the service has changed from cluster IP to load balancer, and it is running this time at 32670. So let me take this guy. Three two 670. Okay, so I can see my Prometheus up and running, and more importantly, if I go to this guy called status, I can see the targets or the machines or the place from where it is scrapping the data or collecting the data. So I can see these many are healthy, unhealthy, and these all are running. I can collapse all, and you can see that there are few servers which are up and running. Now I told that to understand this, you need to learn PromQL or Prometheus query language, which is more of a time series database. So that is not very much recommended way or a way in which the senior management will understand, or a product or a person who is doing L1 kind of support, he will understand. So what we do is we try to make things easy. So how to make things easy, and then when we were working on this, then only my power got disconnected. So here I am going to change this guy stable Grafana, and I will make this guy from cluster IP to load balancer, and I will tell you how is it going to help me. So let me come here, come back here, and I will say something like this. So I'll say kubectl edit the service stable Grafana. So it will open like this, edit, escape, then say I. So you come in insert mode, go ahead, go all the way down here and change again this cluster IPS load balancer. So you can see that when you are using a Helm chart, let me say 99% of the content is correct, but there are some changes which you want to make as per your environment. You can very well do that. So I'm taking this as load balancer. Again, 2 times escape, then colon WQ exclamation mark, enter. So you will see that this guy also got edited. And if I come here and say kubectl get service, I will see the Grafana service also got converted to load balancer. And this Grafana service is running at 30245. So let me come here. Let me run the other service at 30245. 30245. So you can see Grafana is coming up. Now, when Grafana comes up, it will ask you for login credentials. Now, because you have not bought this, you are using a free version. So the username and password will be like something which is known to everyone. So the username will be admin and the password will be prom-operator. So you can come here and provide it. Admin. And the password can be prom-operator. Make sure that you give the password correctly. Prom-operator. Login. Now, Grafana is basically a visualization tool. You have multiple tools like Nagios, Kafka. There are tools like Tableau, Power BI. There are 100,000 tools available in market. Okay, I'm showing you one of that. So let me say that I want to monitor something, or the application which is running, I want to monitor that. Okay, or in my machine only, I have Kubernetes running, and inside Kubernetes, I have 10 pods running. Each pod is one application. I want to monitor that. So what you can do is you can create your own dashboard. When you create your own dashboard, you can add your libraries and all, and you can say, I want to monitor CPU utilization. I want to monitor disk input, disk output, or I don't want to monitor the disk space. I want to monitor the application CPU utilization. So like that, you decide what all you have to monitor. And based on that, you can create your own home screen. So that is one way of doing it. But generally, people don't go ahead by that way. What they do is they simply go here to this guy and they import a ready-made dashboard. So dashboard can be many types. Okay. So one such dashboard which is readily available and many companies are using, I will take that only. So there is a dashboard. I will come here and say node exporter full Grafana dashboard. So you can come here to node exporter full Grafana dashboard, and here you will find a ID basically 1860. So this is what we will be using. So in your Kubernetes shell, you have to come here and simply say like this, dashboard, import a dashboard. Okay, and you can say the number was 1860, and you can load. And you can say this is node exporter full general, and here you can come down and say where is your Prometheus located, because at the end of the day, Grafana will only show you the visualization, but the data has to come from somewhere. So if you see here, there are many sources which can be there, but for me, I am going with Prometheus, and I will import it. Now, the moment I import this, I will start seeing the dashboard. So all the services, everything will start popping up here. So if you come here, I can see my CPU utilization. You can see currently my CPU is 90% getting utilized. The machine which I'm using is 2-core CPU. It has some 190 GB of storage, 2 GB of RAM. This is your CPU, basic CPU thing. Now, let me say I want to see more things. Like, let me come here. Like, I want to see my hardware details. So as of now, no data is there. So it is showing for last 24 hours. I want to change the time range. So I'll say in last 5 minutes, what has happened, you show me. You can see here, throttle cooling devices. There is some cooling device which is running here. I don't want to see this. Let me come here. I want to see the storage. So see how this is, storage is getting manipulated. Okay. Now, let me say that this, whatever dashboard it is coming up, you are not aware much of that. Okay, so don't worry. Anyhow, you don't have to do monitoring and all, so you can ignore this. But still, let me say no. I want to learn how monitoring is done. Okay, so what you can do is rather than using this, you can go ahead and use your own dashboard, and in that own dashboard, you decide what all you want to monitor. Now, one more very important thing which Kubernetes gives, which Grafana gives me is alerting. You can alert in the sense, so if the CPU utilization goes beyond 90%, it means my system is about to crash. So as an admin, I would need to get alerts. So for that, you come here and say, let's create a contact point. First is, okay, this dashboard changes what I have done, whatever I have done. I'm going to save it. Okay, just saving it. Then I'll show you this alerting thing. So here it says that contact point, who is going to your contact point? Either you can create a new one, or Grafana has a default one, so you can go ahead and edit that. If you create a new one, let me edit this guy. So if you come here, you can send notifications by alert manager, ding dong, ding ding ding, I don't know what is that, Google Hangout chat message, Kafka message. You can send it to Microsoft Teams, PagerDuty, Pushover, Sensu, Slack, Telegram. So there are many tools which can be integrated easily. Okay, but mostly the email alerts and all are sent on, or the alert is sent via email. So your email ID, you can put it here. So it will send you email. So now this guy, which is my email ID, it will start getting email. If you want, you can test it. So say it's send test notification. Failed to send alert. Okay, you have to do SMTP configuration. Somebody. Job has breached CPU utilization. Okay, and wait. Let me just go ahead for time being. Save this. Okay, save contact point. This is one thing, but I've saved it. Then what kind of message will you want to send? So I want to send a template message. So here you can come and say new template. Give the name. I will say CPU breach. Okay, and here you can type your message. And come here and say, hi admin. Hi admin. CPU is utilized above 90%. Okay, save the template. So this is the message which will go, and it will go to this email ID, and this is the message which will go. Okay, so these two things are done. Then come here and create an alert rule. So it is just a message. So that message should be triggered. So it will be triggered. Obviously, some activity which should happen. So what is that activity? Come to this alert rule. And here you need to create a rule. So let me say, search by data source. Add a new alert rule. Click here. And now here you will see all the metrics. Now you come here and see what kind of alert you want to send. So aggregator and all you leave. Now alert manager is there. Leave all these things. Alert manager also you leave. So now the Kubernetes related things will come. API server. Okay. So API server audit event. Some audit is happening. So now you want to send it related to API server. It is here. If you want to send related authentication, like there are 3 authentication attempts and all the 3 has failed. It means somebody is trying to get into your server unauthentic way. So you get an authentication attempt error. Okay, then come here. Then related to your cluster. So in the cluster, the CPU ratio is more than 80%. Or in the cluster, for last 5 minutes, it is running at a higher rate. Or you can come here, your API server request has increased above than 30 days normal. Okay, so these are parameters. Then your container CPU utilization, like if I have 5 containers, okay, so let me say container CPU utilization. So it says in container, I'm saying CPU. Now, if I have, wait a second. Wait a second now, let me go down. Take something like that. So I can see these many containers are running inside my application. So if you want to monitor one particular container, okay, you can say like this. So this is A. So you're saying if, okay, this particular container, the container with the ID, which is this, is running, is having the container FS inode total, means the total number of requests for this container ID. Go to down. And put expression here. Expression is when, let me say, the average CPU or average utilization of A is above 30%. Okay, then run a query. So basically it will be something like this. As of now, my CPU utilization is 20%. But the moment it goes beyond 30%, this will get triggered. Okay, or this alert will get triggered. And once this alert is evaluated, preview the alert. And rule name you can give. Rule can be anything. So rule 34. Choose a folder. So let me say I'm create a folder called temp. And group. So let me say is a developer group. If you want to give some particular message, and you can create an alert rule here. And you can save it. Okay, so now if you see, a new rule has been created. This is my rule. As of now, it is normal. Now there are 4 states to any rule. It can be normal, means it is running as usual. It can be alerting, means it is about to breach. And once it has breached, it will come to pending. Pending means the person who has been notified, he has to take action. Like CPU utilization went beyond 90%. So he has to come and take action. You cannot let it run like that. No data means you did not provide the data, so it is no data. And finally, it has failed, so it will go for error. So like this, what we do is we first go ahead and I've saved it, right? So we first come here to alerting. We create alert rules. We create alert contact point, and then what message we want to say. So first is contact point. Who should be notified? So you should give your company's email ID. So what will happen is, if you see here, I have given a Gmail ID. Okay. Now Gmail ID will not work here because Gmail is a third. It will not allow you to. So Gmail is a service where you directly can log in and send your emails. Okay. But if you want that Prometheus Grafana should send email on your behalf, so that will not happen. Okay, that Gmail does not allow you to do that. So when you're running for a company, the company buys the particular domain name, DNS and all. So they can put like this, like @ let me say google.com or amazon.com. So that domain name they have bought. Now because they have bought the domain name, they will have the SMTP server details. Now even I will find the SMTP server details for Gmail. So SMTP server details. Okay, like Yahoo has, iCloud has, Outlook has. But the problem is that if you try this SMTP server details for Gmail, right, it will not work because Gmail is not allowing nowadays. Earlier it was allowing, but now it does not allow you to use these details and ask a third party to send emails on your behalf. So this will not work. And that's why I was getting an error. But the concept remains very clean. The concept says that first you need to create a contact point. You have to tell that if you are sending an email, or if you are sending a Teams notification, or if you are sending a Slack notification, who is the one who has to receive it? So that is first thing which you have to do. Once that is done, you have to go ahead and draft the message, and you have to say what message are you going to send, or what will be the message which you want to send. So here only the message template. So what message you want to send, and then you create an alert rule, means when this should get triggered. So here you can go and say I want to create an alert rule, and here you will get thousands of metrics. Okay, thousands of metrics like API server, container. So this is all for API server. Then authentication related. Then you can see cluster related, code related, container related. If you keep going down, you will see for core DNS related. So let's keep going down. etcd related. Okay, then token related, GOGC related, memory related, instance related. So wherever in the cluster, instance related. So like that, kube config map related, kube daemon set related. So for every activity which is happening inside my cluster, I will have a metrics for that. Okay, so basically there are two things. All these metrics are getting considered or collected, and all these metrics are being used or being configured. Now you can use them for your this thing like kube pod info. You can come here and choose if the container, something like this. So it is saying this is your time series DB or your Prometheus content. So it is saying if pod info for a container, which is this. So this is your A. Come down and you put a condition here. So when, let me say, average of A is this guy, is above, let me say 90%, then you have to take an action. So you have to come here. So for in a span of 5 minutes, continuously 1 minute, this has happened. Preview alert. So as of now, it is normal. That's okay. Then here you create a folder of your choice. Let me say temp2 group. Let me say I want to send it to admin group, and you have to simply come down here and you have to save this rule. So okay, rule name, rule 44. Save it. So basically you have saved a rule. You have told that if the rule get breached, what message should be sent, whom it should be sent, and based on that the message will be sent. So this is one thing. Second is that you will have to come back and either connect to your data source directly. So you can come here and you can say I want to connect to my data source. This data source can be anything. It can be Prometheus, Graphite. So right now I'm showing you Prometheus and Grafana. So I am connecting it to Prometheus, but Grafana is connected or can be connected to every other tool. So if you scroll down now, you will see there are many tools which can be connected. Loki, Elasticsearch. So there are people who will come from monitoring background. They will be very much aware of this. MySQL, Postgre, and all these things. Azure monitoring, CloudWatch. So all these things can be integrated with Grafana. Not that much into monitoring, so I cannot explain much here, but it can be integrated with anything. So one is you directly add the data source, or you create your own dashboard, or you go ahead and import the dashboard. So importing the dashboard is the easiest way of working. Once you import the dashboard, you will be able to see the content, something like this. And this dashboard will give you all the details. Suppose you have 10 worker nodes, so you can do a drop down and you can see everything. Suppose there are 10 jobs running, so you can do a drop down and you can see here. Suppose there are 10 projects, so all the 10 projects can be monitored here. Once you are convinced with whatever you are getting, you can save it and you can share it with your manager or senior team member. I don't want to see for like last 24 hours, so I'll put last 30 minutes. In last 30 minutes, this is what I have seen. When it comes to CPU, this is what I have seen. So CPU usage was like this for me. 1 second, pull it down. Then network traffic. So network traffic was like this for me. Okay, in last 30 minutes. So this kind of data will be first scraped in the sense it will be generated in my Kubernetes cluster. This data will be taken from Kubernetes via Prometheus. So Prometheus will take that data. But if I have to view the data in Prometheus, I need to learn PromQL or Prometheus query language, which I don't want, or companies also don't prefer it. So what they do is they bring Grafana in between, which will be used as a visualization tool. In Grafana, I simply need to come and either create a dashboard or import a dashboard or connect it to a data source. Once that is done, I can view everything and I can also set alert rules by which I can send and receive alerts. Now, for you, if you're joining as admin, okay, you will get a series of documents which will tell you what all alerting has to be done. Okay, so step by step, you have to take care of that. For me, I'm not into monitoring. I've not done much of monitoring. Production support, definitely I'm not done. So I'm not very much aware of that, like which and all is there. But at a very high level, I can tell you that Helm is what I was talking about. Helm makes your life easy by putting everything in a location. And this location can be accessed by anyone who has authority for that. And he can simply download and run everything without writing all these things step by step. So if I come here, I can simply come here and say kubectl get all. So just with one Helm install, I was able to make these many things run. Now I saw that there were two components, Prometheus and Grafana, which were not exposed to the outside world. So I have made it as load balancer, and then I exposed them to the outside world. This is my Grafana. This is my Prometheus. Now I'll open it for questions, and then you can go ahead and ask your questions. So Grafana is taking the data from Prometheus. Yes, Grafana is taking the data from Prometheus. Likewise, what are the other sources where it can take the data from? So I showed you the other sources from where it can take the data from. How to monitor the auto scaling and all also you can monitor here only. So you can come to alerting rules, and let me say we want to create a rule for auto scaling. So scaling. It is now automatic GC cycles. So it is your scaling. So like this, you'll find metrics for auto scaling, load balancing, for everything. You will be able to find a metrics. Let me unmute all of you. I think it is. Yeah, if anyone has any questions, please go ahead.
Helm can be used only, sorry. Helm only can be used on Kubernetes, is it?
Yes, Helm is only used in Kubernetes. Helm is a product.
Nowhere else, no other infrastructure can be used.
I don't think it can be used on anything else. It is only.
Sir, can you please explain in a graphical way? Like starting from
is this. Same thing which we were talking yesterday, okay? See, I started my work here. Okay, I was using Docker containers. Now I moved ahead. I want somebody to monitor my application. So I'm using Kubernetes. But when it comes to Kubernetes, I have to write 100 manifest files, 100 service files, 100 deployment files. I don't want to do all those things. So I go ahead with Helm. Now in Helm, these manifest files are pre-configured or pre-written. So you can just download this from Helm Hub and start using it, just like your Docker Hub. Like in Docker Hub, there is some work which is already done. Let me say your senior guy has put a Docker image. What do? You take that Docker image and you run your content. So any custom requirement, create a Docker image, put it in Docker Hub and use it. Here also you have a custom requirement. Create an image, put it in Helm Hub and start using it. To create a Helm Hub, you need to know what is a Helm chart, which I will be taking tomorrow. Okay. I am
okay. If the manifesto files will be creating tomorrow, right?
Yeah. Can we monitor application URL status and more servers? I think yes, it will allow everything. So these modern tools allow you to monitor everything. So let me just show you if there is a HTTP. So again, if there is a HTTP application, right, I think definitely you will be able to monitor it. This is not a HTTP application. See here. So you get HTTP request in flight and all those things. So obviously you will be able to monitor everything. The data is collected at all the levels.
And sir, the Helm will support only to Kubernetes, nothing else.
Nothing else.
Sir, can you please show us for Kibana monitoring tool also?
Kibana, you can do it individually, man. It was not part of the curriculum. Kibana is separate. I've not worked with Kibana. If you have to work with Kibana, you need ELK, Elasticsearch, Logstash, and Kibana. So I've not worked with that. You can try it separately. In your Helm hub, you will find it. So this is your Helm hub or artifact hub. Artifact hub. Here you'll find Kibana, and how I have done it for this thing, you can look it for that. Kibana is here. So there is a Kibana help chart. You can try it. So you can go through this documentation and you can try it.
And sir,
If you're
one
stuck somewhere,
small
then let me
question.
know.
This is not about today's session. This is general question. In Azure DevOps, no, we'll not be using these many tools, right? And
See, Azure DevOps is a managed service. So again, I'll give you an example of my ready-made t-shirt. And when you buy a piece of cloth from market, when you buy a piece of cloth, you go to the tailor and you say, I need this, I need that, and I want this pocket here, this stitching here. You customize as per your requirement. But Azure DevOps and all are ready-made t-shirt, size number 32, size number 42, size number 46. Whichever fits you, take it, use it. That's it. So you
which
don't
will be available in the inside the Azure only, right?
Azure DevOps is available inside Azure only.
Yeah. Okay.
Sir, we have to nothing change in Prometheus, but we have to only we add alert or anything we want to monitor. So only we have to add in Grafana, right?
No. In Prometheus also you can add. In Prometheus also there is an option. But again, if you want to work with Prometheus, the only problem with Prometheus is that you need to learn PromQL. So if you go to this Prometheus guy running at 32670.
But sir, we don't want to work on Prometheus.
No, it is not at all mandatory to work on Prometheus, and you can read anywhere, any documentation. PromQL is really complex. So
yes,
neither companies prefer it. Not see alerts you can set here also. You can set an alert here also in Prometheus also. So inactive, pending, firing. So these are the stages, and if you want, you can create your own alerts. But you need to know PromQL for that, which companies do not prefer, considering the complexity. And they use some other tool which can simplify things, like I showed you.
we direct can we use direct Grafana, not install Prometheus?
No, Grafana is just for visualization. It will need a data source. So when you install Grafana, it needs a data source because it is to visualize. But from where will it visualize? So you will have to add a data source. So if you come to this guy here, you will see that there is a big list. And this list is nothing but the data source. So you have to tell, okay, my data is coming from Elasticsearch, the Kibana thing you were telling, ELK. Then it is coming from Jenkins. It is coming from MySQL, PostgreSQL, Azure Monitoring, CloudWatch, App Dynamics. So like this, you have to tell Salesforce, SAP HANA, Salesforce.
I think GitLab is also there, sir.
It is all, see, it is an open source. Whenever a tool is open source, it means it will be 99.9% compatible with all the applications available.
So instead of putting our data, pulling it from Docker to Kubernetes and then Kubernetes to other one, we can directly route it through GitHub, no?
That can be done, but again, in GitHub, the code is only there, right? So I want to execute the code, and when the application is running, that I want to monitor. Simply the code, what will I monitor in the code?
Yeah, I got it.
Fine. See you then, guys, tomorrow. Bye-bye.
Okay, thank you, sir. Bye.
Thank you.
Sir, hello.